Now that you have a rough idea how to use Multisim to lay out a circuit, we're going to go ahead and lay out one more series circuit together. Number 2 on the activity shows a 9-volt battery source, a resistance of 470, an R2 resistance of 1.2K, and an R3 of 270 ohms. What I would want you to do is go back to Multisim, and instead of deleting this, we're going to add a new blank page to your project. This is design 1, design 2, and there we go. So we're going to do the same thing, except this time we'll do it a little faster since you've seen some of the basics. We'll pick component, and then from component we're going to go back to sources, place power sources. We'll need DC power, place it right here. We will go ahead and place a ground somewhere around here. We will then switch over to resistors under the basics group. The values they ask for, 470. We'll click OK. Put it about here for now. The other values, 1.2K and 270. 1.2, and you look there, 1.2 kilo ohm. We'll place it here for now, and then finally 270 ohm. Click OK. So get a picture again. Okay, we'll make it look a lot like that again. And we can hit close for now. And we'll take that about here. We'll zoom in a little bit. Put this one about here. So it's on the same line. We'll put this guy down here. We'll pull the ground down a little bit. And we'll go ahead and connect things. Let me move the resistor over a little bit. There we go. We will connect that one. Click and click. And we'll connect our ground. We need to measure 3 voltages plus a current. So we go back to place, component, under the group family, switch it to indicators. We will need a voltmeter. What kind? We will need the one that's from right to left. Then click, from left to right. And then click OK. We'll put it right here. It's a little tight, but it'll work. Then we'll need another one that's left to right. And it's going to be a little tight. We'll put it right here. But now, for the one along the bottom, if we pick the regular one, it's going to measure from left to right. But current is flowing this way. Current is flowing this way. So for the bottom one, we actually want to pick the one that has a different orientation. It's the one that goes from right to left. It will look very similar. Let's close for a second. It will look very similar. The only difference is the orientation of the positive and minus. What does that mean for you in your calculations? It means that you have to watch out that you are not adding a negative voltage. Because what turns out to be a negative voltage really isn't a negative voltage. It's just being measured the wrong direction. Therefore, it's giving you a negative sign. In fact, when we did Ohm's law, we had nothing to do with negative signs. Signs and negative signs in electrical flow usually indicate a direction current is flowing, not that there's such a thing as a circuit where current gets sucked out of. So we'll go ahead and click that here and that here, and U1 will measure the voltage at R1. And then we'll do the same thing here, and then the same thing here. And now U2 will measure the voltage at R2. We'll do the same thing here, the same thing here, and it'll measure the voltage at R3. But we need a current meter. Well, we may be a little space for room. We can click part of our circuit and stretch it out a bit. We can also delete parts of our circuit. Right click delete if we need to remove a trace. Let's go place an ammeter. Component, ammeter, and we'll get the regular this kind from right to left. Sorry, left to right. And we'll put it right here. And then we'll hit close. We'll connect our circuit just like it will connect in resistors. And then we'll compare what we were supposed to create. And right away you should be able to see that obviously the battery has changed on this. It's no longer 12 volts, but the default is 12 volts. If you click on any component in this circuit, you can alter its value. You bring up its properties window. This for the DC power, its label is V1. It's got other reference information. Display wise, value is important. We can change the value of this component from 12 volts to 9 volts and click OK. Likewise, I could do that to my resistors. If I want to change their value, I could edit it right here. But I don't need to do that today. Once the circuit is built, I hit run, and I get 4.638 milliamps. Multisim is bright enough to use SI prefixes. Be careful because from a distance it's easy to neglect that milli and you might read 4.638 amps. Nope, it's milliamps. Over here on my meters, I get 2.181 volts across R1, so a VR1 of 2.181, a VR2 of 5.567, and finally a VR3 of 1.253 volts. So now we can go ahead and stop our simulation. We go back to our activity and let's see what they're asking of us. For number 2, go ahead and add the appropriate meters and voltmeters. Be sure to put your answer properties inside the notation because you're supposed to determine those 3 remaining properties: I sub t, VR1, VR2, VR3. What you need to do for me is go ahead and build this circuit. And once you have built this circuit and tested it and you have your values, you're going to copy this. Multisim is quite forgiving in terms of copying. You can highlight the whole circuit you want in question. It will select all the individual icons, just like if you're selecting text on a document. You can right-click, copy, and then go to a Word document. Create a Word document. Title this problem number 2. Control V. Maybe a little better than that. Let's try that. Change formatting to square formatting. There you go. And move it over here. That's better. And there's your answer for number 2. But let's see if they're asking us any more for this. Add the appropriate mixtures in circuit. Nope, that's it for number 2. Go ahead and give me your copy and pasted circuit for number 2. Number 3, go ahead and do this again using this circuit. Give me your computed values and see if you can measure VR1, VR2, VR3, VR4, and find what I sub t is on a circuit with 9 volt battery source.